slope of a line is the ratio of the vertical change to the horizontal change. Okay, Harry, time to figure out the slope of the line. How are you going to get from 0, 0 to 2, 3? The line has a rise of 3. The line has a run of 2. The rise of 3 and the run of 2 are the same for each section of the graph. Wait, Harry, I think we've got enough to find the slope. The slope of a line is the ratio of the vertical change to the horizontal change. The vertical change of a line is the rise, and the horizontal change of a line is the run. To find the slope of the line, substitute the values for the rise and run from the graph. A rise of 3 and a run of 2. The slope of the line is 3 divided by 2.
Alright, there's two ways to be able to determine the slope. The first way is the rise over run. That's what we'll be looking at first. So we'll take 2 points if they're close within range of each other in the graph, and the points are not counted by a large number. We can just use simply rise over run. So I'm at 0, 0. Gotta make sure you're checking what they're counting by. They're rising by 2 units, and they're running to the right. So when you go up, that's a positive 2. And you go to the right, because everything to the right on the number line is positive, it's going to be rise over 2, run over 3. So our fraction will be 2/3. Now looking at the second example, they're still counting by ones here, so we're going to rise up from one point to the next. We're going to rise up 1 unit, 2, 3 units, and we will run to the right 1, 2, 3, 4, 5. So this slope will be 3/5. Now if you notice from these first 2 graphs, if you look at the graph from left to right, you can tell that that line is increasing. Now, but if we look at this third graph from left to right, that is a decreasing graph. That line is going down. So I know that my slope is going to be a negative number instead of a positive number. So honestly, it does not matter which number you start at, but I'm just going to go from left to right. I will go down 1 unit to be on the same line as this point. So going down is going to be a negative, so that will immediately be -1. And I'm going to go from left to right, so that's going to be positive. I'll go to the right 1 unit, 2 unit, 3 unit, 4 unit. So this slope will be a -1/4 unit. You need to make sure each time that, regardless if it's going to be positive or negative, it's going to be in the whether the graph is increasing or decreasing. What is the slope of this line? Once again, these are close within range, so I can just do simply rise over run. Want to make sure they're counted by ones, and here they are. So from left to right, this is an increasing graph, so I know my slope will be positive. I'll be rising 2 units, 1, 2, and I'll be running 1. That's a 2/1 slope, which simplifies to just 2. Okay, here's our second way that we will be able to determine the slope. And this is once again a graph where it'd be easy to use rise over run method. However, they're just giving you a simple example to be able to show you how you use this. It's a change in the y's over the change in the x's. So now if we can remember that unit rate and our slope, unit rate is the same thing as slope, and our unit rate is y over x. Well, if we have 2 y's and we have 2 x's, so we want to find the difference in those. So my formula that I use is y sub 2, which is the second y, minus y sub 1, divided by x sub 2 minus x sub 1. You can still honestly subtract. You can still use the equation y sub 1 minus y sub 2. You just got to make sure you're subtracting either the first y's from the second, and so on with the x's. So when I plug in this equation, I have that Let's do my first example. We know an ordered pair is represented as x, y. So here's my first ordered pair. So this is going to be my first x. That's called x sub 1. And now here's my first y, and this will be y sub 1. Now going on to my second x, it's my second order pair, so this will be x sub 2, and then y sub 2. So I now can just use this and plug it into my formula. So I'll do 4 y sub 2 minus y sub 1, which is 2, over x sub 2, which is 2, minus x sub 1. Now understand that this is minus, but you're still subtracting a negative 3. So this is when you dance and two negatives turn into a positive. So 4 minus 2 is 2. You dance and this will be 2 plus 3, which is 5. Our slope is 2/5. Moving on to B. The easiest way to not make a careless mistake on this is to label it x sub 1, y sub 1, x sub 2, y sub 2. So I'll plug into my equation, my formula, which is negative 5 minus 1 over 8 minus 6. When you have two negatives, signs are the same. You add the two numbers, which is 6, and you keep that sign. Now 8 minus 6 is just 2. You have even numbers with 2 being the denominator, so this will simplify to negative 3. Negative 3 is the slope. Moving on to part C, once again label. Make sure we don't make a careless mistake. And plug into your formula. 4 minus 4 and 1 minus a negative 2. That's going to be the most common mistake. Now 4 minus 4 is 0, and you dance. 1 plus 2 is 3. Now notice here, this is an exception to many rules. If you have a 0 on top of a fraction, the answer is just going to be simply 0. But when the 0 is below, is on the denominator, it will be under a number which is described to be an undefined solution. I'll do one more example of this. I'd like you to pause this and try it on your own. So you do negative 2 minus a negative 3. Careful on that. Careful on signs. And negative 1 minus 5. So on this top equation, we'll dance. Minus a negative. That means negative 2 plus 3, which is positive 1. And signs are the same. You add the number and you keep that sign. So that's going to be a negative 1/6. This last part, we rise 2 and we run 0. So let me show you the graph for that. As you can already see though, 0 is on the bottom. So 0 is on the bottom of the fraction is undefined. And this is what an undefined graph looks like, because you'll rise 2 units, but you will not run any. So you'll rise 2, run 0. That'll be 2 over 0, which is undefined. I'm going to show you real quick the close and check. Give you a few examples to work if you need it. And the solutions.